Hi class, this is section 6.2 Properties of Parallelograms. Our learning target for today is that we will be able to use properties of parallelograms to solve problems. So first let's do a quick review of always, sometimes, and never. A trapezoid is blank a parallelogram. A trapezoid is never a parallelogram because a trapezoid only has one set of parallel sides while a parallelogram has two sets of parallel sides. A square is blank a rhombus. A square is always a rhombus because the properties of a rhombus is that it has two sets of parallel sides and all sides are equal. And a square has two sets of parallel sides and all the sides are equal. A parallelogram is blank a rectangle. Sometimes a parallelogram is a rectangle. It's a rectangle whenever all of the angles are 90 degrees. A kite is blank a quadrilateral. A kite is always a quadrilateral. It has four sides. So now we're just going to focus on parallelograms. Our first theorem says that opposite sides and opposite angles of a parallelogram are congruent. So looking at parallelogram ABDC, the opposite angles are congruent and the opposite sides are congruent. Knowing that, if I told you to find x and y, what would you need to do? Well, ZW and YX are opposite sides, so you would set those equal to get that x is equal to 4. And 3y and 36 are opposite angles, so that means that y would have to be 12 for both of the angles to be 36. Now consecutive angles. Consecutive means next to, so we're looking right here at B and D, those are consecutive. A and B are consecutive. Consecutive angles are going to be same side interior angles. Because A, B, and C, D are parallel, that means that these two angles would be same side interior or consecutive interior, which means that they are supplementary. So when you're looking at a parallelogram, consecutive angles are going to be supplementary. Next theorem. The diagonals of a parallelogram bisect each other. So here's parallelogram ABDC. Here's a diagonal. Here's a diagonal. And bisect means to cut in half. So where the two diagonals meet at x, they're cutting each other in half. So AX and XD are congruent, and CX and XB are congruent. Knowing that, let's try a problem. If TY is equal to 3x and YR is equal to x plus 10, find x and TR. Well, I know TY is equal to TR because that diagonal is being cut in half. So I set those two values equal. You get 2x is equal to 10 and x is equal to 5, which means TR is equal to 30. Now you have to plug this 5 into both of these expressions to get the whole diagonal TR. So it'd be 15 plus 15 is equal to 30. Theorem. If three or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So that's a mouthful. Let's look at a picture. If I have these three parallel lines and a transversal going through all three of them, say that the parallel lines are cutting this transversal into congruent pieces. That means that between these two parallel lines it's congruent and between these two it's congruent. Well, no matter what line I draw, it's going to be congruent. Knowing this, let's find EH. So I show you that it's congruent segments. So that means that EH would be 4 plus 4 plus 4, which would be 12. These are all the properties of parallelograms. The first one says opposite sides are congruent. The second one says opposite angles are congruent. The third one says consecutive angles are supplementary. And the last one says if a parallelogram has one right angle, then it has 4 right angles. If you think about that, you can use the theorems up here to show that, because opposite angles are congruent, so that means if one's 90, the one across from it's going to be 90. And then we know consecutive angles are supplementary, so if one of them's 90, then the other one has to be 90. So J and L would be 90, K would be 90, M would be 90, which means if it has one right angle, then they're all right angles. The diagonals of parallelograms are going to bisect each other. And here's another one we haven't talked about yet. If you draw on one diagonal of a parallelogram, it's going to create 2 congruent triangles. ABCD is a parallelogram. Find AB. Well, the side across from it is 30, so that's going to be 30. ABCD is a parallelogram. Find the measure of angle C. Well, angle C is across from it, so it's going to be 36. ABCD is a parallelogram. Find the measure of angle D. Angle D is consecutive to angle A. That means they're supplementary, so D would have to be 144. WXYZ is a parallelogram. Find the value of R. Well, here's 4R. That's a side. The side across from it was 18. So you're going to set those equal and get that R is equal to 4.5. I want you to try this problem on your own. You will need to have this completed for class. Have a great day.